Hey, welcome everyone. Good afternoon and welcome to our weekly seminar series here at the Dahdaleh Institute for Global Health Research. My name is Professor Mary Viktorovich and I'm the acting director for the Dahdaleh Institute. Today, I'm delighted to host Sherif Shuaib, who will be leading today's seminar entitled Predicting Adaptations in Canadian Fishing Communities and Rapid Climate Velocities. As is our usual practice, I'd like to begin by acknowledging the Indigenous land that we're on. This is a hybrid event, and some guests are on different territories, so please take the time to give thanks and respect to the land on which you're currently living and working. Today, I'm here on New York University campus in Toronto, situated on the traditional territorial area known as Tkaronto, and we acknowledge its current treaty holders, the Mississaugas of the Credit First Nation. We acknowledge this as the traditional territory of many Indigenous nations, including the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. This territory is subject of the Dishwas One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. So let's begin with a brief introduction to our speaker, Sherif Shuaib, who's a graduate scholar here at the Dahdaleh Institute and currently pursuing doctoral research at the Department of Mathematics and Statistics here at York. He's analyzing the repercussions of environmental stressors on marine species distribution and abundance using mathematical approaches and machine learning technologies. Sherif holds a Bachelor of Technology in Mathematics and Computer Science from the Federal University of Technology in Nigeria, and a Master of Science in Applied Mathematics from the Prince of Songkla University in Thailand. So in today's seminar, Sherif will explore the relationships between fishing and climate velocity to assess the impact of climate change on the abundance and distribution of marine fish. He'll discuss the systemic review method he used to find the correlation between climate change and habitat modification, that's giving insights into how fishing communities adapt to species variations. So this is a 1-hour event that will end at 2. We'll start with a 20-minute presentation from Sherif, followed by a 30-minute question and discussion, and then we'll wrap up at about 2. So I'd now like to give it over to you, Sherif, to talk about your interesting research.
All right. So Mary, thank you so much for the introduction. I mean, I don't think I would have done a better job than you just did now. So thank you for that. So like Professor Mary had said, I'm part of the Congress Research Group, and my supervisor is Professor Jeff Kong at the Department of Mathematics and Statistics here at York University. So basically, I mean, this is my research in a nutshell. I'm trying to understand the impact of climate change on fish distribution and abundance, where I'll look into topic modeling and sensitivity analysis. And I'll also create mathematical models to understand the impact of climate change. But today I'll be talking about the systematic review, which is the first one here. It's a literature-based analysis, and what we intended to do is to predict the adaptations of fish and fishing communities to rapid climate velocity in Canadian waters. So this is published in the Environmental Advances Journal. It was published last year, so in case anyone is interested to go back and read it. So I mean, due to the time of presentation, I'll just briefly show you what I did, and I'll start with the introduction, followed by the methodology, the results, the discussion, the conclusion, and the acknowledgements. Okay. So now to the introduction part. So we all are aware of the impact of climate change. For marine species as well, this is not hidden to, I mean, it's causing different range shifts. It's causing habitat change. It's also causing expansion of the species and fragmentation as well. And the fishing and fishing communities are greatly affected by this. This is because the fishing communities need this as a source of income. They rely on this to live. So as we all know, Canada is bordered by 3 water bodies. We have the Arctic Ocean, the Pacific Ocean, and the Atlantic Ocean. And communities along this 3 coastline rely on the $3.5 billion marine aquaculture and fishery sectors But because of this climate change, it's actually threatening their viability. So, I mean, due to this, there is a reason and a pressing need for fisheries to see how we can adapt to the shift so that at least we won't really lose all the fishes to climate change. Based off of this, my supervisor and one other colleague decided to explore the following research questions. And the first one is to explore the adaptation strategies that are developed by fishers and fishing communities to kind of navigate this challenge. The second is to investigate the identification of incentives and policies that will be crucial to promote the sustainability of marine life. And the last one is to assess the effective utilization of distribution and bioclimatic models. Since my research is in mathematics, I would like to know what types of models have been used to study the impact of climate change on fishing. I mean, we all agree that by addressing these complexities of climate change, we'll be able to study the impacts and kind of give good recommendation to policymakers to consider about. So now the methodology used was a systematic review. I mean, what is a systematic review? As its name implies, it involves like a detailed plan and a search strategy. And the aim here is to reduce the bias by identifying, appraising, and synthesizing all relevant studies on a particular topic. Here are the steps to systematic review. The first one is to identify the types of problem you would like to work on, which we did already in the previous slides. Then you have to search the literatures relating to this problem. Then you screen the potential studies you feel that will be useful to you based on your inclusion and exclusion criteria. We'll talk about that later. We extract the data we need, we analyze the data, we do our reporting. And in case there is a situation whereby you've missed like a query and you'd like to go back to it, you can go back in step 7 by updating and performing all the steps once again. So let's start with 1. So like I said, you need to design a string or a query to search on your preferred database. Here, we're searching for Canada. I mean, because Canada is the country we're focusing on. We have the Beaufort, the Baffin, the Hudson, all these are types of seas in Canada. And we also have the North Pacific Ocean, Arctic and Atlantic Ocean. So we're using the Boolean operators and or, meaning we'd like to search a research in Canada that has fishing community, I mean, that is predicting, forecasting, projecting, assessing and analyzing, and it's focused on marine species, and it considers climate velocity, climate change, or thermal habitats. I mean, some other researcher might decide not to use this and create a new search query entirely. It is not specific. You can do anything you want in systematic review. And there are a lot of databases you can search with them. The first we did was to search on ACM Digital Library. The second was to use PubMed. The third was to use Google Scholar. The fourth, Scopus. The fifth, IEEE Explore. And the last one is Web of Science. So we search this query in all these databases with the hope of getting different records, number of publications that have been carried out on this research. So what, again, we can use different software when doing systematic review. In my research, we used EndNote, but you can also have Distiller, Providence, and Rayan QCRI. So what result did we get from searching the database? The first one is we had 4,246 from Web of Science. We had 5,230 from Scopus. In PubMed, we had 1,304, IEEE was 11, and Google Scholar was 405. So the first thing we did was to duplicate the records. Why are we duplicating? So for example, if Hannah here is publishing in Health System and Reform, and I'm sorry to use that as an example, Health System and Reform is indexed in 3 types of databases. We have the Collaborate Analytics, we have the Medline, which is a sub-database of PubMed, and we have Scopus. When we try to download all this, Hannah's paper from this record, we'll have 3 copies of Hannah's paper because the journal Hannah is trying to publish to is indexed in all of them. So we need to duplicate it because we only need one. So when we duplicated our records, we had 1,426 duplicates. The next thing is to screen the records now. In systematic review, I mean, we decided to go with 2 steps of screening. That's the first screening and the second screening. So after taking the duplicate records from the entire records, we had a total of 9,743 records to be screened. And how are we going to screen it? We screen it based off of this criteria. The first thing is the paper we downloaded, is there an abstract to it? If it's a yes, we proceed to the next one. Is the impact of climate change on fish studied in the record? If it's a yes, we proceed to the third one. Does it employ a mathematical or computational model to forecast fish distribution? So recall I said we are theory in number that actually took out the research. In a case where I decide that Hannah's paper should be included in the second screening, and my colleague Fatima decided that no, I don't think it should be included in the paper, we proceed to Professor Jude. We send the paper to Professor Jude, and he decides on whether the paper should be included or not. So after that, we had 2,771 for the second screening. We excluded 2,738 because in the second screening, we're doing a complete screening of an entire paper. It's a fast one. We are skimming and scanning at the same time. So based off of some certain criteria as well, by doing that, we had only 33 studies. So from these 33 studies now, we want further ahead to just kind of look at what papers really relates to what we need. And by doing that as well, we had 23 papers, which was included in the research we published. So what are the things we looked at for in the 23 papers? We looked at for the publication year and title. We looked at for the geographical location. What are the research objectives they study? What types of fish species they considered? What type of model was to use? The type of data set, their key findings. What is their perspective on the quantity and distribution of marine fishes? And what impact do they have on fishers and fishing community? All right, like I said, these are the steps to take from my fast explanation. I'm really sorry. We're done with problem formulation. We're also done with searching the literature. We're done with screening. We did data extraction now. So data analysis, it's a form of systematic review where you analyze it statistically. We didn't do that yet. So I'll proceed to reporting and dissemination. All right, so what types of models were found in the study? This was my third research question. So mathematically, we have 3 types of model. Okay, we have the process-based or mechanistic models. These are the models you see where you have the mathematical equations. And these equations follow some ecological principles to simulate the interaction of fish and their environment. We have the phenomenological or statistical models. These are models derived using statistical techniques, okay, such as regression analysis, machine learning algorithms. Then we have hybrid models. There are some studies that combine both model 1 and model 2. So recall I said we had 23 articles in our final screening. I mean, how were they shared amongst this models? 3 articles worked on process-based or mechanistic model. 8 articles worked on phenomenological or statistical model, and 11 worked on hybrid models. 11, 8, 3 is 22. There is one remaining. The last one could not be fit into any of this model. So, I mean, to just kind of study the impact of climate change on fishes, you would need to, before you select the type of model you want, you need to identify the types of data you have. You need to have an ecological knowledge of the type of fish you're studying. And you also need to decide on the objectives you want. That will give you a clear indication of what type of model should be used. Okay, so I've talked about the types of model, but specifically moving in detail, what are these models? We noticed that a lot of models used, a lot of articles used species distribution model, which is a form of the correlative models, while some other used the general additive models. So moving ahead, what are the impacts we found on fishers and fishing community? The first one we realized was that there's a study that predicts a 20 to 50% decrease in harvests and a reduction in 3 to 4 types of tuna and billfish in Central North Pacific fisheries. And also, we also found that by the middle of the century, maritime channels such as the Northwest Passage, located in the Canadian Arctic, will become more accessible, meaning the ice will continue to melt. This is not a good indication for the environment. So lastly, there is a challenge now in managing salmon and herring populations because like we have 100 First Nation communities that rely on these two types of fishes. And when these fishes are reducing, then it becomes an issue because how will the communities adapt to the declining fish population? So where are they migrating to now? The first is, for instance, Arctic cod. Initially, they were in southern part of Canada. We noticed they are moving to the northern part of Canada. Atlantic herring, it's always inshore and inactive near the coast. But now it's moving towards the southern regions. But however, they do that only in the winter because of the climate velocity. Atlantic mackerel is off the coast of Canada in winters and early spring, but they are closer to the coast of Canada in summer. Striped dolphin, minke whale, northern bottlenose whale, white big dolphin are moving from the further south to the north, while mink and the last two are moving to the southern latitudes. So what are the incentives to sustain marine life and economical balance amid climate change? Some studies have suggested we use predictive simulation model based on global environmental data. And others have suggested projection as they feel it will assist regional managers in identifying what types of species will likely experience significant changes. And by doing that, it would give us an idea and provide us with a tool for the management groups to just try and commence communication with the communities before this threat actually comes into play, so they can plan ahead for this. Another study I've talked about mitigating efforts by slowing down the pace of climate change. By doing that, we'll have adequate time and we'll have opportunities to create and develop and also implement proactive policies. Others have suggested partnering with affected nations by implementing strategies that could involve shifts in fishing areas, target species, and fishing agreements. So now also studied what is the current situation in the Arctic Ocean, the Pacific Ocean, and the Atlantic Ocean. I'll start with the Arctic Ocean. First, the Arctic Ocean is getting warmer, and by 2070, the sea will not be covered by too much ice. This is not really good for the environment. However, for trade, this is nice because all these ices, the ships will be able to just pass through and deliver items from one country to another country. So for Arctic Ocean, the sea ice is disappearing faster than even what the scientists had earlier predicted. For the Pacific Ocean, in the last 80 years, the ocean surfaces near British Columbia coast has been getting warmer by about 0.7 degrees Celsius. And once this gets warmer, this becomes challenging for organisms or fishes that prefer cooler temperatures. An example of this fish is Atlantic salmon. So because they prefer cooler waters, it affects them, it affects their habitat as well. And also the increase in temperature can cause harmful algae to grow, and it will all affect the fishes and also the food chain in the sea. For the Atlantic Ocean, it is also getting warmer, and it's caused due to ice at the poles to melt. Water levels are also rising, ocean currents are shifting, and the water is becoming more acidic. Animals in Atlantic Ocean, such as shellfish, marine mammals, and seabirds, are really not doing well in this kind of temperature. So what are the climate change impacts on Canada's ocean? Like we've talked about, we are currently having ocean surface warming. There is acidification. There is polar ice melting. And this are affecting the marine ecosystem in Canada. Which areas do we think are really affected? We have the Gulf of Alaska, the Scotian Shelf, the Hudson Bay, the Beaufort Sea, and the broader Arctic Ocean. So how are the communities adapting to this climate change? For now, I mean, we realize from the studies we review that fisheries quantity and economic value in Canada, Teresa, is stable for now. However, with this impending danger of climate change, it will definitely lead to shifts by making species move their locations from one place to another. And it's right now the policies that would really help them needed to be made to kind of safeguard the fishes in Canada. So first, I would like to acknowledge my supervisor, Professor Kong, and my colleague, Fatima Noor. We took the studies together. I mean, thank you for them. And I'd also like to thank the Dahdaleh Global Institute. When I got the email from Mary, I mean, if I was interested, Professor Mary, sorry, if I was interested to have a presentation here, I'm like, I've always walked past this building and I don't know what is happening here. For sure, I'm taking this opportunity. So thank you, Professor Mary. Thank you, Hannah, and Teresa as well, every other person involved. And to our funders in Congress Research Lab, we're funded by NSEC, we're funded by New Frontiers in Research, also funded by IDRC. And thank you all for listening. I'll be happy to take your questions.
Thank you so much for a very interesting presentation. So would anyone like to begin with a question, or I could also go ahead. No, you go, I'll reserve one.
Thanks for your talk. My name is Chloe. I'm a research fellow here. I was just curious whether any of the models you all found did kind of intervention scenarios and looked at the impacts of some of the adaptations or policies, or whether those were more in the kind of recommendation space, but they didn't integrate them into the model.
Yeah, I mean, we didn't specifically go into details reporting what this model did in terms of intervention. I mean, we only wanted to identify the types of model that have been used. Yeah, so that's a research gap there in this research.
Okay,
I'm really
so you weren't sure whether they did
yes.
more kind of predicting the impacts versus doing.
I have a question regarding your method. You talked about acidification. Sorry, apologize. Thank you for the presentation. I really thoroughly enjoyed it.
And introduce yourself.
Oh, okay. My name is Nell. We had before.
Yes.
So hello again.
Hi.
So my question is related to the method, right? You used a systematic literature review. I see that you used climate velocities, climate change, and thermal. Right? Why didn't you include acidification? Because clearly that also impacts the physical chemical properties of the water, which would affect habitat and food, etc. Well, did you run any pilot searches which sort of showed, indicated that acidification was not needed?
No, we did not run any pilot searches on acidification. I guess we just considered anything relating to climate change or climate velocity. Yeah, that will capture climate community. I mean, it's all good. It's a nice way. That's a research gap as well. And I guess maybe if we consider acidification, we might get better results than this. But actually, you can consider that the method are not limited to anything. You can try anything you want. But for us, I guess it was an oversight, and we just wanted something relating to climate change, anything climate. Yeah.
Thank you.
You're welcome.
Okay, I don't see any more hands up here. So my question relates to, I mean, first of all, very fascinating study, really interesting, especially, going out into thinking about the future and where we're going. I think it's really vital research. My question relates to confounding factors. Like, for example, I know there's a lot more fish farming, and there's some problems in those fish farms, antimicrobial resistance, for example. So I'm just wondering to what extent something like fish farming might have an impact on migration of the ocean species.
Yeah, I mean, again, If this was a literature review, we would have definitely captured that. The difference between a literature review and a systematic review is you're telling the system to kind of bring out some studies for you.
Right,
So if we didn't capture fish farming, we're probably not going to get any studies relating to fish farming. No.
Right.
Yeah, so I'm able to kind of just answer that part of your question,
okay.
yeah.
Do you think it's relevant to look at in the future?
No, I actually think it's really relevant to look at in the future. I mean, when we did the study, we actually planning to carry, because we did this in 2022. The last search date was in August 2022.
Right,
So I think 2023, we had 12 months, a lot of papers would have been published.
right,
So we're thinking of, okay, adapting the code now, the query, like she has talked about certification, which I'll definitely look into. We've talked about fish farming, which I'll definitely look into. She has also talked about the interventions by the model. So those are things I would consider in the next phase of the research.
okay, great, thank you.
Another, which might be something you looked at or something to add, but I'm always interested with modeling studies, if any stakeholder engagement was done, like was there any, did the authors do any work to try and make those models more accessible or usable by, say, decision makers? So you talked a little bit about like fishery management and how the findings could kind of guide some of their decision making. So I was just curious whether in any of the studies there was any mention of that, like how do we share these kind of models or findings with decision makers, or do that like knowledge translation piece?
Oh.
I know it isn't always included in academic outputs, but I was just curious if that came up at all.
Can you please go back to the first slide? I mean, I'll answer a question with this first slide now. I didn't really touch on it because Professor Mary did the very first one. And the second one. So now we're currently doing this study, like a global assessment of actors and their roles in the adaptation of fishing communities to rapid climate change. I mean, that is one of the things we are considering. So, I mean, by the end of this research, if I'm lucky enough to get another invite from Anna and Teresa, I'll definitely come to give you the answer to your questions.
Awesome.
Yeah.
And just as a follow-up to Chloe's question
Mhm.
around potential stakeholders, have you developed sort of a knowledge mobilization plan? Have you, because, you know, this kind of analysis would be important for decision makers and farming communities.
I mean, we've not thought about that, and that's a very good idea, but we've not really looked into that. I mean, I guess because so I'm kind of more leaning to the mathematical aspect of the research because
Right.
my department is mathematics. But like in the other studies I just mentioned, I'll probably just try to consider that as well.
Yeah, or maybe engage with someone in environmental studies.
Mhm.
They might be more into knowledge mobilization as well, could
Mhm.
support you as well. But,
Thank you so much, Professor Mary, for the comments. I mean, you can ask anything you want.
I don't have a math background, so if we have time, would you be able to just give us like a snapshot of the differences between predictive modeling and species distribution? What scenarios would we use predictive as opposed to the species distribution model?
All right, then. I mean, Hannah, I mean, everybody needs me back, so you probably have to bring me back here. But in terms of mechanistic model, for instance, you're dealing with a lot of equations. That is a proper mathematical equation. But with phenological models, you're really into the statistical aspect of the research. You're trying, you have your data really dictates the type of model you're going to use. If you have data with a lot of variables, you'll probably lean towards a statistical model. Where you don't have a lot of equations, but now you're trying to forecast, you're doing different things with phenological models. But in maths, which is the mechanistic part, you see a lot of equations you don't even want to touch. Yeah. So I mean that's the only difference when I can just highlight for you. But since you're always around, I mean I can pop up into you one day and say, okay, this is the answer to your question.
Oh, okay,
Yeah.
okay, all right. Thought you sounded in some trouble there. Thank you.
You're welcome.
So just as a follow-up, is this your next stages of research, can you talk about them a little bit? I know they're probably mathematical, but usually a systematic review would inform the next step or,
Yes,
yeah.
sorry, can you go back to the slides again? So, I mean, I'll start from this in response to your question, Professor Mary. So since my department is really into the mathematics part, here is a research tab in the first one, which is the process-based or mechanistic model. By doing this review, we realized that not a lot of models has been done in this research. Like you recommended, most people prefer to run away from the mathematical part itself and decide to use the statistical or correlative models. So moving on, I mean, I formulated a model already based on process-based and mechanistic to answer my research question. Okay, so that's the first one. And sorry again, can you go to the first slide? So I'll touch on the machine learning now aspect of the research, which is something we are considering as well. I mean, we completed that already as well, but we've not gotten approval from my supervisor to just kind of publish it. But what exactly are we looking at? We are hoping to do, we did topic modeling and sentiment analysis. We'd like to understand what are fishing communities complaining about. Okay, I mean, what are they saying in relation to climate change? And we use the Facebook data sets we analyze the data sets to just kind of know what they are saying using NLP, natural language processing. That is one part of my research as well. And the other part which I talked about before was the global assessment of actors. So actors now would like to know who are the people now involved and what are their roles to just kind of what are their roles in adapting to climate change? Actors, we mean individuals like us. What is Daniel doing? What is Shasta doing to climate change? Educational institutes. What is York University doing? You know, so that is what we are looking at. So it's a global one, and we're halfway done for that particular one. I guess I'll have to start it all over again based off of the comments one or two people suggested here. So by actually looking into trying to answer one or two of the questions as well. And the last one I talked about already is the modeling part. I mean, we formulated a discrete time stage structure model. So let me take it again, discrete time, meaning we are looking at what is happening at regular intervals, not at a continuous stage. The fishes are more, you can model fish continuously or discretely, but the best way to model them is discretely. And we are looking at the stage structured model. So we have different stages. The fishes, you have the juvenile, the adults, all these types of stages. We are considering only 3 stages in my research: the juvenile stage, the young adult stage, and the adult stage as well. And yeah, so I mean, the battery is low there because we've just done 15% of the research, but we are looking to extend the model now. The model did not capture any effects to climate change for now. In modeling, we would like to just have a basic model first, do a lot of simulations to see where we can actually get into trouble, I mean, in the long run. So but now we're done with that and we're trying to extend this model now. What the model will capture is the climate parameter, we call it parameter. We'd like to include the climate parameter to rate, and that is what we're looking at. So overall, to answer your question, Professor Mary, these are the things we're considering for now.
Great, thank you.
So can your PhD committee or your supervisor committee, do you have someone who studies who is an expert on fish ecology? Because I think it would be very interesting, based on your findings, even just to look at a subset on dolphins. You know, one species is moving one way and the other species is moving, other 3 species are moving the other way. So if you're looking at the climate parameter, maybe the biological parameter or the species-based specific parameter, it'd be interesting to see the correlation between the two. Like, why is one species doing exactly the opposite to the other 3 species?
Yeah, sorry, are you?
Yeah, sorry.
No, it's fine. So in my committee, I have Professor, I think Professor Sharma. I can't really remember her first name. She's a biologist.
Oh,
So we have her, and I guess that's why the battery there is very low, because today we decide on this, tomorrow we try it out, it's not really working. So including the parameter nights, it's a very interesting and difficult space of the research. Because ideally we are considering temperature, but machine system will have to consider oxygen as well. So I mean, just fitting them to actually fit into this model is really a great issue. But thank you for the comment. But we're trying our best to see what will come out of it.
Are you dropping any teasers to the fishing, the human side of the research, like in terms of mobilization?
Sorry.
The trading, like the fish trading or the private, the sellers, what's a better way of saying it?
In the fishing community?
Yeah, the fishing community, like, should really, part of the mobilization should be dropping some hints on what you're doing, because this is really, really pivotal research.
Yeah.
Everyone can reap benefits of.
I mean,
Make the money up. Think about it already.
all right.
Yeah, the folks who don't go to the research literature and, yeah,
Yeah.
wouldn't even know how to access it.
And that's a huge broader impact of the research. Just have to find those people that
I
are
mean,
interested in listening. And you're great, like, I don't have a background in math, I understood everything that you just talked about, so that's amazing, thank you.
Thank you so much.
Even the media, the newspapers, it could be interesting,
Yeah,
Or-
absolutely.
yeah, that's right, so. Maybe, I think there's some knowledge translation folks and the, York Research Office, you can share it with them, and they'll give you some ideas for how to phrase it so that it's interesting and it'll get picked up, yeah.
All right. Maybe I'll have to start tagging along with you anyway, you go to, so
The
you can.
hook, you gotta look for the hook,
Yeah.
the broader impact of the model.
All right,
Yeah.
then. Thanks a lot.
Thank you.
All right, and anyone online, any follow-up? Okay, so, well, thank you so much, Sherif. That
Yeah,
was
thank you, Professor
really,
Mary.
you can tell we're all fascinated, so all the best in your next steps in your research.
All right. Thank you so much, everyone. Thank you for
Okay.
saying it.